Okay, so solving radical equations, a simple style would be something along these lines. And the ones I'm going to do today are just square roots. Cube roots will be a similar process, fourth roots. So if I want to solve this radical equation, I am going to get rid of the square root. And the way you do that is to invert it off by squaring both sides. Because the square root of x minus 3 times the square root of x minus 3 is going to be x minus 3. And when I square both sides, I get this side 64. And when I continue solving, x will be equal to 67. But one thing you have to do on these is always check them. So we're going to take the 67 and plug that back in for x. And the question is, when I do that, do I get 8 for an answer? And as you can see, it does work out. So if I come up with a little more complicated one, before I could square both sides, I have to get the radical right there isolated. So I'm going to subtract 15 from both sides. I'm going to divide by -3. And you should be able to follow that. Sketch it, pause this and sketch it out. Make sure you get this next step. But it should be square root of x minus 5 is equal to a positive 15. And square both sides. So square root of x minus 5 squared equals 15 squared, which is 225. The radical's eliminated. X minus 5 equals 225. X equals 230. Check it. Plug 230 in for x. And you see it checks. Now here's an example, and this is a good example for two reasons. One, we should be able to look at this and see it's not going to have a solution. The reason is, I can't take the square root of a real number and get negative. Okay, so that's not happening. I know there's no solution. But if you don't catch that, you're going to square both sides. And when you square both sides, you get x plus 12 is equal to 16. Okay, and when you solve it, you get x equals 4. Check it. Well, when you put 4 back in there, you get square root of 16. And square root of 16 is equal to 4, not -4. So no solution. All right, now this one's a little more complicated, and you might want to pause multiple times. You notice I have two radicals. And when I have two radicals, I'm probably going to end up squaring both sides twice. So you just deal with it. I square both sides. That means I have to FOIL out this monstrosity on the left-hand side. The right-hand side is easy. It's just x. And pause it and check my foiling. Make sure you get the same thing. But you'll see it works out to be this. The x's will subtract off. I'm going to move the 3 and 4 to the other side, but when I do that, they become a -4. So right now, I know there's no solution. Okay, but I'm going to continue on just showing you what I would do. Again, I would square both sides, and it's a toss-up if you want to divide by 4 and square or leave it here. But I have to square the 4, which is 16. I have to square the square root of x plus 3, which is x plus 3. And I have to square -7, which is 49. X plus 3 equals 49 over 16. And when you work this out, it comes out to be 1/16. Now, you can go back and plug that back in for 1/16 in for all these x's, but I know right there, there's going to be no solution. The process is you square to get rid of a radical, you isolate the next radical, you square again, then the radicals are gone. But every time you square, you're introducing what's known as extraneous solutions, so you always have to go back and check.